So today we're going to look at how to build a workflow engine in TypeScript. We will look at some code, some theory as well, and we will see a practical use case. But of course, we can build whatever use case we want. I'm Alfonso. Again, nice to meet you. In case you want to have a chat, let's connect on LinkedIn. I'm a tech lead at Nearform. Who knows about Nearform? Ooh. Okay, nice. If you don't know about Nearform, well, we are sponsoring this amazing conference. So in case you are interested about the company or what we do, we have our great colleagues at the stand. So go and check it out. We also have some prizes that at 5:30 we will do some giveaway. So in case you're interested, go for it. Let's start about talking some, what is exactly a workflow engine? This is something that I asked myself a few months ago when I started to build such a tool. Let's start by a definition, like very simple. A workflow engine is an application, like a piece of software that can automate, manage, and execute a workflow, can route your data, can do a bunch of things, basically run some logic. And I basically built a project, let's say a toy project, that we will look in a moment. And the first time I presented this internally in my company, they asked me a question that makes a lot of sense. We have a lot of things that can do that can route data and do basically workflows. Why did you create such a project? The main reason is basically to learn new stuff. Did you create like a pet project in your life, something just to learn for fun? Oh, wow, okay, nice. So basically, if you want to learn a new language, a new framework, a new whatever, you can just create a new pet project. Sorry, I forgot to put the timer here. Okay. And so the goal of this project is just to learn a lot of stuff. Don't use that in production unless you want to break stuff. In case you want to use something in production, some workflow engine in production, you can use Zapier, make Apache workflow. Have you looked into any one of those? Like, have you played with something in the workflow space? Okay, a few hands. Okay, that's nice. Node-RED is quite popular in the Node.js ecosystem, but in case you're interested, just check it out. Now, for our workflow engine, we need a couple of components. The first one, which is the most important, which is the engine itself, which is basically a TypeScript engine that we are going to look into later. We're going to see the exact code of the engine. And then we need, if we want, of course, we need an application that can let us use that system, which is basically an application to build the workflow, an application to see the workflows and to see the inputs and the outputs and how all the steps are going. Let's see an example, right? Because we are talking for a couple of minutes already, but we don't know what we are talking about. In case you're interested, there is my short link here on my website, alfonsograziano.it/engine. In case you want to try it out on GitHub, you can basically just clone it and run npm install, and you can try it out. So let's imagine a scenario. We have a Grafana dashboard, or we are doing some application monitoring. Who's doing here application monitoring, by the way? Oh, okay. I'm not gonna comment on that, but everyone should do some application monitoring here. But if you do application monitoring and you have some alerts, in theory, you want some alerts via email, I don't know, on your Slack. So the incident that I have in mind, the scenario that I have in mind is that something like Grafana can send me messages through a webhook, in this case. And in case I have a warning, so a really simple warning, I just want to get an email. But in case there is a critical issue, I want to receive an email with all the details in a human readable format. So I built this workflow, which is quite simple. So we have our webhook, we have a conditional plugin that checks for the severity, and then in the case of the warning, we are just sending an email. But in case it is a critical issue, something that we have to act on at the moment, right now, I created a very simple ChatGPT plugin which formats the content of the webhook in a human readable language and sends the email. Of course, we can trigger the webhook with Postman or anything that we like. And then this is the output. So we are transforming this input, which is basically just JSON code, into a human readable string that we can read, and we are sending that through email. Of course, the options are unlimited when we talk about no-code and low-code tools. Of course, we can build, in case the underlying tool is power enough, we can build whatever tool we want, whatever workflow we want. In this case, of course, we are going to focus on something very simple. Okay, let's build the engine. Let's start building our engine. Let's see some code. But sorry about that. We have to learn some theory, just a little bit, the bare minimum, but we have to look into some theory first. Let's imagine a graph. I'm not sure folks who graduated in computer science or any stuff like this, but when I started to study graphs, I told myself I'm never gonna use that in my life. But interestingly enough, I use that at moments like quite a lot. So in case you don't remember about graphs, it's basically a very simple yet powerful data structure where we can represent nodes and edges. Now, if we want to represent a graph in JavaScript, it's quite easy. So we can represent it like this. We just need to keep in mind what are our nodes. We need to give them some IDs or some form of identifier. And then we need to create some connections between those nodes. So on the left, we have a data structure in JavaScript. And on the right, we have basically the visual representation of this very, very simple graph. In the case of a workflow engine, we want a specific type of graph because, of course, the graph is a very generic data structure. But we need, in this case at least, to add some constraints, some rules. So we want a DAG, which is a direct acyclic graph. We need to enforce some rules within this graph. So the first rule that we have to enforce is that is acyclic, as the name implies, right? And then we want to enforce also that is one single graph. So we want to ensure connectivity because we can have a graph which is composed of multiple pieces and it's still a valid graph. But in our case, we want those two cases, we want those two conditions to be met. And in order to do so, as you may guess, we can write some code. Easy. So first of all, we have some code to do some cycle detection. So as you can see here on the right, we have our webhook, then we have a couple of steps, then we send an email or we do whatever we want, and then we go back into the hello world, which is basically just doing nothing. It's just printing hello world. Now, we want to avoid having this arrow here. We want to avoid having this cycle. And in order to do so, we can just write a simple function which checks for every node and run a DFS, which is a depth first search. And we check that we don't have that we are not reaching again the same item. Same applies for the connectivity validation. So basically what we are doing here, we are starting from the first item and then we are going downwards to all the connections and we are trying to ensure that the number of reachable steps from the first item is equal to the number of steps, like the total number of steps that we have in the graph. If we do so, basically we can ensure that we only have one, that our graph is composed of one partition. So these are the two validation steps that we have to do. If we want to talk about the tech stack, like super briefly about this application, as you may guess, the main component is TypeScript, the main language, as the name of the talk implies. But there are a couple of interesting tools that I want just you to know. So the first one is React Flow, which is quite a popular library in the React space for building stuff with graphs. Has anyone used it like before? Oh, okay, a couple of hands. Okay, that's nice. So in case you want to model a graph or some connection between stuff, you can use React Flow, which is quite powerful. Then undesigned just because I'm too tired of writing Tailwind or other CSS stuff. And then, of course, Typebox to ensure type safety, Fastify, and just Redis for the caching mechanism. So basically, as a queue, I'm using Redis as a queue, and then Postgres to store all our data for the web application. We need a few concepts. We need a little bit of glossary that we can reuse to understand better the concepts. So first of all, we have a template. It's like when you define a class. So when you define a class, you define all the methods and the attributes. And also in this case, we need to define a template, like a blueprint of our of the workflow. First of all, we have the workflow template, which is basically everything together. It's all the steps, all the triggers, all the connections, all the data, like the name, whatever. So the workflow template contains everything. Then we also have the step. The step is basically the unit that gets executed. Sending an email, sending a Slack message, running, I don't know, DALL-E to generate an image, doing whatever, uploading a file on Google Drive, whatever. So a step is basically a single unit of computation. It might even be just running JavaScript or running a new Docker container, whatever. Then we have the trigger. Of course, we have to start our workflow from somewhere. So we can have multiple triggers, webhook, a queue, a cron job, whatever we can think of. And then we have, of course, connections between our step. So every time I go from one step to the other, I got a connection. Let's visualize that in our tool, in our web application. So as you can see here, everything together, it's the workflow template. Then I got the trigger, which of course can have some setup. So for example, in the webhook trigger, I can say, okay, this is the endpoint that I have to reach. These are some security headers in case I need any. Those are the HTTP method, get, post, whatever, usually a post. Then of course we have the steps. So for each step, we have to define all the properties, all the inputs and all the outputs. Because as you may guess, I need to send an email. What are the information that I need to send an email? I need, I don't know, the sender, the from, the to, the subject, the text. So all this information will be stored within the send email step. And then of course we got the connections. So from this execute JavaScript to the ChatGPT plugin, we have a connection. Once we run a template, we create an instance, like for example, in the example of the class, every time we create a new instance of a class, we got an object. And the same applies for the workflow run. Basically, every time we create a new workflow, we have a workflow run. And every time we run a step, we have a step run, because we mentioned that the step must have an input, but that input might be resolved dynamically, which is something that we will look into later. And we can also have some trigger run, because maybe in the case of the webhook, I can send dynamic information that I want to use later within my workflow. And here we are, same applies. So workflow concept visualized. As you can see here, you don't need to read this code, but the idea is that I save all the information from my trigger. I save all the details because I then can reuse them later. And same applies for the step run. I have the step run, and I can save the output of my step in an output object, which I'm going to reuse later as input for other steps. I did some technical choices. The most important one is the laziness-driven development. Who has used this technique before? Even in production. Come on, folks. Oh, okay, a lot of people. So basically, I want to build something which works, which is nice, but I took so many shortcuts. That's why you shouldn't use that in production, by the way. Apart from that, this might be an interesting technical choice because I just decided to have almost zero error handling or very basic error handling. It means that if we have a workflow with 100 steps, if a single step fails, I'm gonna let fail the entire workflow. We don't have retries, we don't have partial failures, we don't have partial success, nothing. If something crashes, the entire workflow explodes, which is funny. The first thing that we have to look into is the plugin ecosystem. So we mentioned that we have a step, which is a single piece of execution. And basically, every time we run a step, we run a specific plugin. In this case, here, there are some plugins that I created just for example. But the cool thing is that you can build a plugin in literally, at least with this tool, you can build a plugin with something like 10 lines of code or even less. The idea is that in order to build a new plugin within this tool, you just need to create a new file, export a new class, and you just need to have two methods. One for introspection, which is the get plugin info, which is used to retrieve from the application the ID, the name, the description, the inputs and the outputs that we will use later. And then you just need a very simple method, execute, which, as you may guess, takes in input the inputs and returns some outputs, which are stored. So this is like super, super easy to create a plugin. You can create it from your Slack, or you can even add new libraries, whatever you want. Then, of course, we have to define our inputs and outputs. And here I'm using Typebox. You can use whatever whatever tool you want, like Typebox, Zod, anything that you wish. Again, you are not forced to use a specific tool here. As soon as we defined all our plugins, we can now trigger a new run. So let's assume that we created our workflow within the application. We can trigger a new run. Again, how do we do that? We can have a webhook, which is waiting for to be called. We can have a cron job. We can have message queue. We can define our own triggers. That's why it's so powerful, because we can, in like 30 seconds, create a new type of trigger. Then we can implement how the trigger is triggered again. We just need to, the only things that we have to do is we have to find the trigger. And as soon as we find the trigger within our database, we need to save the trigger run with all the information that we want, and then we can schedule the workflow. And from there, it will be picked up from a worker. Now, here is the interesting part, or at least what I consider the interesting part. How does the engine works under the hoods? Now, we are going to look into each one of the steps. The idea is, the main idea, the high-level idea is that you have an entry point. So we have a single entry point step. We run that step. In order to run it, we resolve all the inputs. For example, we get information from the triggers. As soon as we resolved all the inputs, we execute the plugin, which has been loaded at runtime dynamically. Then we fetch all the next steps that we need to run. As soon as the single step is ready and can be executed, then we execute it. And basically what we are using here is a promise chain. So we are basically calling recursively the function run step with a promise chain. We will look into that in a second, but let's start to look at the first piece. So basically, every time we define a step, we mentioned that the step has some inputs and can generate some outputs, right? So the first idea is that I need a way to say to the system how to fetch the specific input at runtime. Let's assume that I need to look at the variable isAdmin here. We know that is false, but how can I understand whether the variable at runtime in the specific context is false or true? Well, we need a way, in JSON at least in this case, to define what is the input source, where it's coming from, and on what path I need to look into it. What we do is basically we pass those two information. So basically this descriptor and the entire context, which is the output from triggers and the other steps. We pass all this data as input to a function, which is basically a function that does interpolation of these values and generates these values. These values are the real input for the plugin. If I want to execute the plugin, it's super easy. So basically what I have a plugin registry, which is loaded at runtime. I look at that plugin registry based on the step type. So I can see, I don't know, step type is send Slack message, whatever I want. And I can create a new instance of the plugin and execute the plugin with the inputs that I resolved. And of course, at the end of this execute plugin, I'm going to take the outputs and I'm going to return the outputs. As soon as I do that with the execute plugin function, we can look at a little bit higher level. So the steps are, first of all, as we said, resolve all the inputs with the step ID, execute the plugin, and as soon as we execute the plugin, we store our outputs into a repository. Now, the cool thing about having a repository pattern here is that basically I can store this information in our database, in Redis, like even in local memory where I need it. In case there is an issue, as we mentioned, so I'm gonna just let the entire workflow run fail, basically. I can say that the step run is failed, and I'm gonna say that also the execution itself failed. In order to find the new steps to run, that's interesting, because we mentioned that we have a graph. So from a single step, I can have something like 10 steps after. So I need one way to find all the steps that are generated from my plugin, from my single step. So the idea is that I'm going to get all the incoming connections from the graph. I'm going to look at the graph structure, and I'm going to say, okay, please find me all the possible steps that I can execute now. I'm going to look at all the candidates. So basically, we have some candidates that can be executed. And I'm also going to look at something which is interesting, which is the conditional plugins. So the idea is that maybe I have 10 possible plugins that can be executed, but maybe I don't want to execute all of them. Like, let's assume that I have a conditional plugin which is doing some branching. I don't want to execute all the plugins. I might just want to execute one or two options. So we have one function, which is this one, which from the output of a step, I can define what are all the steps that needs to run later. This is super interesting for me, at least has been super fun to write this part of code, because let's assume that we have a scenario like this. So we have step 1, which went well. We have step 2, which went well. And we have step 3, which is still running. I don't know, step 3 is maybe an API call or something that is taking a lot of time. Now, can step 4 run? Not yet, because maybe step 4 needs some information from step 3 in order to run it. If I try to run step 4 now, I'm going to fail because I don't have all the outputs already collected. So I have to wait. I have to find a way to wait. In this case, in the second case here, I have step 2 and step 3, which are done. Therefore, I can proceed with step 4 because I have all the information that I need in order to proceed. This is called basically dependency-based execution. It means that we can see step 2 and step 3 as dependencies for step 4. And as soon as all the dependencies are resolved, then I can proceed with the next step. In order to look at the dependencies of a step, first of all, we can compute them. Now, we can compute them at runtime, or we can compute them beforehand. In this case, what I prefer to do is just compute them beforehand. So I can look at all the connections, and I can create this dependency count. That's super easy. Then when I have to execute the steps, I can basically, thanks. Then when I have to execute all the steps, I can basically look into it and I can say, okay, did I resolve all the dependencies already? Can I proceed with the next step? If I can proceed, I basically go to the execute step. That's why the function is recursive, because this piece of code is still in the execute step function. Therefore, I'm basically building some recursions. If it is not, like if I have some dependencies that are still running, I am basically removing one dependency from here because the current step just finished, and I'm just doing nothing. I'm just waiting for the other dependencies to be complete, and therefore I can continue. Now, I just want to give you like a couple of interesting things that I found while writing this code. There are some cool libraries and things that I used. And one of those is this JSON rule engine. If you're a nerd like me and you like building complex logic into the declarative way, you might like it. So basically, the idea around this engine is that you can declare your JSON, and you can declare some rules within your JSON, and you can inject some facts. And this JSON, like this rules engine, will check at runtime whether the conditions are true or false. And it will allow you to evaluate some conditions and build some events, like create some events. Of course, you can write your own rules. So in case there is something, they already have a library of rules, of predefined rules. But in case there is something that you don't have yet, you can just write a couple of lines of code and it's done. In the case of conditionals that we mentioned, so basically I have this simple conditional here, which will decide whether I'm going to go into the hello world or whether I'm not going to do anything. How do I understand that? But well, here I just use, again, you don't have to read this code, but the idea is that I have some rules which are defined in JSON, and then I have some facts which are basically the variables that I'm injecting at runtime on this tool. Again, this conditional plugin is going to use what we saw earlier, that function, and basically that function is going to output this specific property, which is like a magic key. You can see it's like a magic key. And this magic key is going to tell us, okay, this is the next step that you have to execute within the workflow. And that's how you can do branching. And you can do, like, this is a very straightforward example, but you can do like super complex branching in this using this approach. Okay, folks, I'm almost done. I just want to tell you that this project needs some love. So in case you want to contribute to your first open source project, which as you may see, in Nearform, we love a lot open source. So in case you want to contribute, at least even for the first time, to an open source project, you can just create me a PR. You can just download the tool, see where it breaks, because it breaks, open an issue, do whatever you want. But in case you are interested in contributing, here is the short link. Or I think with that, we are going to share the slides. And that's all. Thanks a lot for your time. And in case you have a question, I'm here.